So I will going to start on the Internet of Things. So I will go through the basic things in the Internet of Things and architecture, what is the IoT world, sensors, and what are the hardware components, communications, cloud computing, and data analytics, and IoT security. So all this part is there for the Internet of Things. So this will consider so many things uh, like hardware, sensors, and cloud, and protocols, device protocols. So so many things will be covered under the Internet of Things. So so I will just give you the basic concept, like what is actually the Internet of Things. So this is this is not a technology, it's just a concept. So these things were already there from the long back, but if you combine so many things, like hardwares were already there, sensors were already there, cloud it came, and internet is there. So combination of all the technologies into one single page, so that is what we call it a IoT. So it's covers a huge prospect, like uh, in the case of the hardwares, embedded, and clouds, analytics, and so this is all the part of that only. So if you have gone through the Gartner cycle, so Gartner have suggested these top 10 technologies in the next 5 or 10 years in the IoT. That is a major one is IoT security, IoT analytics, and device management, low power short range IoT networks, and wide area networks, IoT processors, IoT operating systems, event stream processing, and IoT platform and IoT standard ecosystems. So the major worry right now is IoT security. So IoT security, suppose I will just give you example, like why it's a major concern in the IoT. Suppose uh, you get any alert or anything related to your home automation. So nobody should breach anything in case of the alert, or they should not able to control your devices. So the security is a major concern right now in the IoT field. So right now there are very few implementation is there, but as far as idea is there, so many companies they are going to implement the TLS, and if they are doing the OTA, OTA means over the air update of the firmware from the cloud. So in that they are implementing the SHA1, SHA 128, 256 or MD5 for the IoT security. And the next big thing is the IoT analytics. So whatever the sensor data is there of the devices, suppose I give you one example in the home automation. So whatever sensor is there, its data will be logged to the cloud. So whether you take the home automation, industrial automation, or utility, energy utility, so this data will get logged to the cloud. So you can do the analytics based on that. What is the analytics is going on behind that. So you can presume on the future basis when the more sensors will be coming into that. So you can do the analytics, and then this big data and all this concept will come under this. So the next thing is IoT device management. So as per as Gartner's cycle, if we'll go through that, then they have assumed like by 2020 there will be like 13 to 15 billion devices will be connected to the network. So it's a huge devices. To manage that devices, it's a big challenge currently in the IoT. So suppose I give you one example. Suppose in the industrial automation you have connected so many devices, but to interact each devices with each other, it will be a big challenge to identify like from which device you're getting the information and all. So that is the next point. So now the connectivity between the devices. So suppose you have a gateway and you have a multiple sensors in your home or in the industrial automation. So how devices are communicating with each other, that's That's a big thing. So in that case, uh, there are so many protocols are there, so many alliances are there. So right now, like if you go to the alliances, like few hardware companies and software companies, they have created their all join alliances, and they are still working on that. There should be one proper and protocol will be there that should help to communicate between the devices. So it will be quite easy to send the data from one device to other device. So in this range, there are so many protocols are there, like BLE is there, Z-Wave, ZigBee. So these are the low power short range IoT networks. And so in this case, these protocols are more feasible in the IoT nowadays. And there's a new technology is also there, LoRa. So all these details I will explain you in the further presentation. So and the other thing is the low power wide area network. So in this case, uh, 6LoWPAN and wireless LAN, these things comes into the picture. So and next thing is the IoT processors. So nowadays, so many hardware companies are coming into the embedded domain, and they're looking into the IoT devices, IoT gateways. So Intel, ARM, and Qualcomm is there, TI is there. So they have their own gateway devices nowadays. They're coming up with their own IoT devices right now. So like Intel, if you go through that, they are coming up with the Curie and IoT Intel Edison and Intel Galileo. So their main focus, Intel Galileo is only for the industrial automation. Their purpose is for that only. And they have also launched the Intel Edison, that is especially for the BLE and Wi-Fi based chips are there in that. So that is only for the wearable devices like smart watch and heartbeat rate. So those types of devices, it is for that. And the other thing is operating system in the IoT. So in the actually in the IoT, memory and memory is a main constraint. You cannot put so much like Linux system is there. For it, you cannot consider the same thing for the OS in the case of the IoT. So there's few OS is there that is for the IoT only, like Tiny OS and Conky OS. So these OS is mainly getting used in the case of the IoT. They have their own protocol like Conky OS that will be having a 6LoWPAN protocol for the device communication. So that is the thing. And next is the event stream processing. So how the stream processing of the data of the large base, how the devices will manage that, that is a big challenge. And next thing is IoT platforms. So IoT platforms, nowadays so many companies, they have brought their cloud platform uh, like if you take the Microsoft Azure, they are coming up with their own IoT hub. Amazon have their own IoT hub. Xively, Exida, PTC. So these companies are coming up with their cloud platforms. So that is a main challenge in the case of the how the device is communicating to the cloud platform. So that is the next big thing, because they will follow the all own protocol in the case of device communication. So next thing is IoT standard and ecosystems. So as I told you, there are so many companies are there that are coming with their own alliance, like Microsoft and Intel and a few hardware companies and the cloud companies. They have created their alliance to come up with their own protocols to communicate between the devices and devices to cloud. And even the Qualcomm and Google and Amazon, they have also created their own alliances to work on that part. So this is a detailed idea about the next 5-10 years for the top IoT technologies. So next I will tell you about the Gartner hype cycle. So if you see in the graph, so there is a, this is graph is for the next. So this graph is for the next 10-year prediction, like what actually it is. But this is actually the hype cycle. If you see that curve is increasing and coming down, and then it's straight almost. So in that case, IoT is already reached to the hype, but now that part is coming down and then it's going flat. So still so many things, so many technologies that will come up, but still few were already there. Few is coming in next 2 to 5 years. Few will be in the reality in 5 to 10 years or more than 10 years that will take. So if you see the graph here, that yellow color mark that will be predicted like that will come into the picture actually after more than 10 years, and then the dark blue is indicate that that will come up in the next 5 to 10 years. So you can predict it like what technologies and what idea will come up in the next 2 to 5 years, 5 to 10 years in the next in the coming years in the IoT. So now I will tell you about the basic things like what is the IoT architecture. So here if you're seeing in the uh, figure there, so this there are so many devices are there, so that actually the sensor or the actuators which will give you the actual data, and this data will be go to the gateway that will be using any of the protocol like device communication protocol like Zigbee, Wi-Fi, BLE, 6LoWPAN, LoRa. So these are the device communication protocol. So using this device communication protocol, you will receive the data from the sensors to the gateway, and gateway will be having some inbuilt cloud protocol. So that will send the data to the cloud, and from the cloud you can do your analytics based on the data you have received there. So this is the flow of the IoT architecture. So that data you can retrieve it on your phone. You can go to the data on your phone using the analytics. So these are the things in the part of the IoT architecture. So I will tell you the basic like what is the IoT hardware platforms. So as you heard, like I told you earlier, Intel Galileo, they are coming up. Intel have their own Galileo or the Edison devices. That is actually the hardware platform for the smart home, industrial automation, and the building automation. So actually they use here the Quark SoC, and they're coming with their own BSP package on the top of this. And apart from this, Arduino is there, so it is quite cheap to start it because Arduino Uno and Mega, so it's quite feasible to implement if they come up with their own IDE, and it's very easy to start if nobody know what is the actual IoT. So it's a good thing to start it first from the Arduino Uno. And BeagleBone, so BeagleBone Black is there, Raspberry Pi is there, ARM, Mbed, Intel Edison. So these many IoT platforms are there to start on the IoT. So the best thing is Arduino Uno, so we can do the practicals and the programming and the implementation of the actual IoT scenario on the Arduino Uno, and later we'll see what we can do more on the other devices. So next is the IoT communication between the devices. Suppose you have a gateway like Intel Edison, and you have end devices, some sensor is there, you will have to push the data to the gateway. So this communication protocol will very much help you to post the data to the gateway. So the communication will be between the two devices. One is the actual sensor and other one is a gateway. So Zigbee, if you use a Zigbee, Zigbee is just like a communication protocol, and they come up with the hardware. So Digi and Amber, Silicon Labs, they have, and NXP, they have their own Zigbee standards. Sorry, no, they have their own Zigbee devices, and they all follow the Zigbee alliances for the communication. So if you have implemented the Zigbee, so you will have to go to the Zigbee certification to get that confirm, like you have a Zigbee certified devices in your product. And other one is Wi-Fi, Ethernet, NFC. So these are the other technologies we can use in the case of the device communication and device communication. So next is the comparison. I will just tell you the brief comparison, like what is the difference between the communication devices. So here if you see, I have categorized a few things based on the device communication of network range, join time, and data transfer rate, and what is the advantages and disadvantages in this scenario. So if you see Zigbee, so the network range is up to 50 meters. So actually in Zigbee, there are so many um, um, categories there. So just like uh, Zigbee Pro, Zigbee basic version. So based on that, range will get increase or decrease. So the main advantage in the case of the Zigbee devices, while device-to-device communication, is a low power Zigbee lens. So suppose I give you one example. Suppose you have one sensor. Sensor is like you have kept at your door your motion sensor. If somebody is coming, it will give you alert like somebody is on the door. So in that case, if you just plug that with one 3.2, 3.3 volt battery with that motion sensor, in that case, that device, that life of that battery will be around 2 years to 3 years. So you can use that. So it's like it's take quite less energy or the less power. So it is used for that scenario. So there's a, I will tell you about the use case and all those things. We will discuss it later. And but the but the main challenge in this case is low data rate. So if you want a very frequent data, so in that case, it won't help you that much in the case of Zigbee communication. But it is suitable for the smart grid and smart home. So apart from that, Bluetooth smart ready is there, and so this is like Bluetooth, like normally in your laptop or that BLE devices are there, and in your mobile you are seeing like Bluetooth is there. So with the Bluetooth, the range is up to 100 meters, and data rate is 3 MB per second. So within a second you can connect it, and so it won't be an issue. And easy mobile connectivity, and installation base is quite high, because if you see the smartphone, so nowadays everybody is having a smartphone, so that connectivity and install base is quite high in that case. So but if any devices is there on the Bluetooth base, like suppose heartbeat rate, so that centered communication is quite less. So still it is required in the future. That is a future challenge right now, and it is basically more suitable in the case of mobile-based services. Apart from that, Wi-Fi is there. So its range is up to 90 meters. Connectivity is in few seconds you can connect it, and transfer rate is quite high. So that is not the problem in the case of the Wi-Fi. And the main challenge is high power consumption and busy network. So that is a quite big challenge in the case of the Wi-Fi. And next is Z-Wave. So Z-Wave is range is up to 90 meters, and you can create the simple network using the Z-Wave or the mesh network. So mesh network I think you know, or I will tell you the little idea. If you, it's based on the one topology is there in the communication. So in the mesh network, suppose we have so many devices and one coordinator is there. Coordinator means suppose your gateway devices is there. We have integrated the gateway. So the gateway will be considered as a coordinator, and other devices, suppose any sensor is there, so that will connect as a router, and other end devices will take, so that we can also consider as a, we can take it as a sensor with the end devices, but that end device will not be directly reachable to the coordinator. But if you will have to get that data, so the flow will be end device will send the data to the router, and router will send the data to the coordinator. So is a mesh network, or the each router to router communication or the end devices to router communication is comes under the uh, mesh network. So in the Z-Wave it's take quite low power, but very limited nodes and low data rate, and suitable in case of the security and the smart homes. And NFC. NFC in the, I think you know, like in the most of the smartphone, its inbuilt is there. So it's quite safe, secure, range is quite less, and but it's quite costly. Normally we used in the case of the payment and access control. And next thing is Bluetooth Smart. So this is like this days you are wearing the smart bands and heartbeat read and all those things, fitness devices wearing nowadays, you guys. So in that case, this device is very useful, or this protocol is very useful in that scenario. So it's take the quite low power consumption, and it's based on the 4.1 BLE Bluetooth Low Energy Communication Protocol. So after this, I will tell you what is a IOT or M2M protocol. So suppose you have reached the data using this device-to-device communication protocol. Like suppose we have two devices. One is a gateway, one is the sensor. Sensor has send the data to the gateway. So gateway, after receiving the data from the end device, gateway will push the data, want to push the data to the cloud. You will get the data, you want to push the data to the cloud. So in that case, we use some cloud protocol like MQTT, CoAP, Continua, DDS, HTTP, REST, XMP. So these are the major cloud protocols to push the data. So I will just give you the little idea about the comparison of these protocols and what is the messaging format they follow it actually. So in the case of the CoAP protocol, they follow the transport layer. That is transportation is the UDP, and the messaging concept they use the request and response. And connectivity is on the 2G, 3G, and 4G. It's quite excellent, and it's and low power, and in that case it's also quite excellent. And security is in this scenario is optional and a medium level, but it's used in the most of the cases of the utility field area networks. So and they follow the three architecture in the CoAP. And other one is Continua HTTP. So it's also follow the UDP transport, and it's based on the publish and subscribe request response. So these things I will give you more detail further. What is this request and response and public and subscribe? And apart from that, it's on the 2G and 3G protocol. It's quite fair, but not that good based on the communication. But Continua HTTP is used more in the case of the medical devices, and Other one is a DDS. It's follow the UDP protocol, but again, its messaging is a public subscribe request and response. So security is high. It's mostly used in the case of the military. Other one, the major one I will tell you is the MQTT. So nowadays, this is getting more useful in the case of IoT. It is based on a public subscribe request and response. And on a 2G, 3G, and 4G, it's because of low data, its quality is excellent in that case. And slow power also, it's quite good. And but security is a minimal thing in that case. So later all these protocols I will give you the brief idea. And these are the cloud platform, basic cloud platform which nowadays companies are getting used. So Xively is there. Xively is basically more on the MQTT side. So the MQTT is actually based on the, you will have to trigger the packet, and based on that they will be having some control channels. So those, because using that control channel, you will be able to public and subscribe the packet. So this actually Xively works on that side. Apart from that, Exida, Thingiverse, and other cloud platforms is also there. So I will just give you like a basic difference, like what hardware they have support, and what operating system they are using in that in the most of the scenario. Xively is getting used in the BeagleBone, Raspberry Pi, and ARM Mbed, and even on the Arduino and Intel Galileo, it's quite easy to integrate on these devices. And Intel operating system they're using is the GNU, Linux, and embedded C, C++. And in the Arduino side, they come up with their IDE and the library. So using Arduino, you can just integrate their IDE, and you can push the data using the MQTT to the cloud platform. So that's quite simple and easy to push the data. So other thing is Square, ThingWorks. ThingWorks is also there. So ThingWorks comes with their own gateway as well. Oh, sorry, they support the Digi gateway and Intel Galileo, and their programming language is ANSI, C, Java, MQTT, and WebSocket. And Exida also supports Intel Galileo and Arduino also. And they come up with the Digi gateway. They also support a Digi gateway, and they come up with the operating system of the GNU and Linux and Arduino support. Apart from that, other Sensi Node and Groovy Stream is also there in the case of the cloud platform. So this is a thing I will go through further in the future, like on this cloud platforms and the compatibility with their hardwares. So that's it from my end. Any question? Okay, practical. So okay. So on the practical side, I will explain you like on the Zigbee how the communication will happen, what all the softwares and what the communication will be required. Suppose you want this Zigbee to Zigbee communication. So those things I will explain you, and how the Arduino works. I will give you the basic program, how to get the fetch the sensor data, and how to send the sensor data to the any of the cloud platform. I will help you to build the cloud platform on the Linux machine, like Microsoft Azure cloud platform, that I will help you to build and push the data to the cloud. So those things I will explain you on the cloud side as well. And a basic thing to start on the Arduino, you know. So those things I will cover up in the programming side, practical sides. Anything else? System configuration, those all details I will share. Suppose Microsoft Azure is there. To set up that, we required a few hardware configuration, or the Linux. If you have a Linux machine also, you can build that Microsoft Azure on the top of that, and you can easily able to push the data or if you're not using any sensors apart from that, also you can push the data to the cloud, Microsoft Azure. And if you want to push the data using the Arduino Uno, also you can directly, I will also help you to integrate the Xavli cloud on that, and we can see like how the data is getting pushed, and we can also see the graph and all, everything I will cover up in that. Prashant, anything else?